The essential question for this section is, can you predict the difference between angle of elevation and depression? Can you predict the difference between angle of elevation and angle of depression? Hopefully you have some type of a prediction. We're going to define these terms first. Angle of elevation is formed by a horizontal line and a line of sight looking which way? Good, looking up. Angle of elevation is formed by a horizontal line and a line of sight looking up. So that means that angle of depression is formed by a horizontal line and a line of sight looking down. Down, very good, down. Everybody all right with that? Let's draw a picture of it. The picture we're going to put, this is the ground. This is a hill. Got someone up here standing on the hill. Very happy person standing on the hill. This is a hill. We have another person down here. They're happy as well. They're standing on the ground. Just got their hair did. A horizontal and a line of sight looking up. This is an angle of elevation. A horizontal line and your line of sight looking down, that's angle of depression. This area right here, this is called be careful. That's the be careful area. Right in here. Come on, yellow. highlighter today, I guess. And I'll show you why when we do a couple of example problems. Look at example problem 1, angle of elevation. Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? So you're going to take these angles of elevation and angles of depression today, and you're going to use them and sine, cosine, tangent to solve these problems. So we've got the ground down here, and then we got this castle. Told that the castle is 190 feet tall. You got Leah over here. She's 5.5 feet tall. And she's looking up at the top of this castle. And she's forming an angle of elevation of 38 degrees. They're asking how far is she from the castle. So we're going to take this information that's given and we're going to form a right triangle. And with the given information, we can use sine, cosine, or tangent to find out this distance right here. We need to know how far she is from the castle. So in relation to this angle of elevation, how far she is from the castle is the adjacent side. The opposite side, you got to do a little math right here, and this is where you need to be careful, because they told you this castle is 190 feet tall, but they also told you that she is 5.5 feet tall, and this triangle that we formed that we're going to use to solve this problem is not on the ground. It's 5.5 feet above the ground. So if you take your 190 and you subtract this 5.5 feet, it gives you this opposite side of the triangle, which is 184.5 feet. So now, in relation to this 30-degree angle, you know what the opposite side is. You're trying to find the adjacent side. Opposite and adjacent is tangent. So we're going to use tan 38 equals opposite over adjacent. And I'm just going to use the letter A for adjacent. So to solve for that letter A, we need to multiply both sides by the A first. The A's on the right will cancel. So A times tan 38 equals 184.5, and you can divide both sides by tan 38. So your adjacent side, or the distance from her to the castle, is the 184.5 divided by 38 tan, 236.1 feet. Everybody okay with that? Do you see why you need to be careful of this area in here that I can't highlight? be sure to make the adjustment to this third side of the triangle, or this opposite side of the triangle. In this case, it was the height of the castle minus the height of Leah. Got it? Alright, good. Take a look at example 2 on page 581. Angle of depression problem. A search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to this person? So here's the water, green water. Here's your helo. Copter. Your helocopter is 18 feet above the water. There's another person in the water that needs help. Nervous person in the water. Your angle of depression to that person, okay, angle of depression is formed by a horizontal line and a line of sight looking down. 42 degrees. The question is, what is the horizontal distance from the rescuers to the person? You need this number. Here's your horizontal distance. So since we're using a horizontal line and a vertical line, this is a 90-degree angle, so it's a right triangle. We're dealing with an opposite. No, we're not. Not yet. Not yet. See this 42-degree angle of depression right here? It's formed by this horizontal line. Well, this is a horizontal line as well. So those two lines are parallel, which makes this diagonal an alternate interior. I'm sorry, a transversal, which makes this angle 42 degrees. These two angles are alternate interior angles by definition. So in relation to that angle, we're dealing with opposite, and we're trying to find the adjacent again. Opposite and adjacent is tangent. So tan 42 equals your opposite side, which is 18, over the adjacent side. I'm using A again. Same steps as the last problem. Multiply both sides by A. These A's will cancel. Divide both sides by tan 42. The tan 42's will cancel. And your adjacent side is equal to 20. So your horizontal distance from the rescuers to the person that needs help is 20 feet. Anybody have any questions on angle of elevation and depression, or either of the examples we did? All right, your assignment for today is write it's right on page 583. You're going to do problems 1 and 2. And then problems 1 and 2, and then 4 through 6.